My name is Justin, and I'm here today to tell you some stories about the incidents that I've dealt with while being an on-call engineer in the AWS Cloud9 team, and the ways in which some recently released AWS services and functionality can help you to reduce the amount of time you spend on such incidents. So if you've ever had to be on call or had to try and juggle multiple technical problems while your management and customers are on top of you looking for answers, then you're in the right place. I'm a solutions architect here at AWS in Brisbane, and I was previously an engineer on the AWS Cloud9 team before that. And for those who don't know, Cloud9 is a cloud-based IDE that allows you to write and run code right in your browser. Also, a quick reminder first, this is a level 300 session, so I'll be assuming some familiarity with AWS services, and I may not expand on the definitions of a few of the more widely used services and tools as we go through this presentation. So we've got a pretty simple agenda today, but there's a lot of depth to cover on this topic. First up, I'm going to just set a quick baseline for what it means to be on call and having to respond to high severity incidents. Next up, I'll be giving a breakdown of how I recommend teams should respond to high severity incidents based on my experiences here at AWS. And then I'll dive into each major action I've recommended, along with a demo of some of the hidden gems in the AWS observability space that can help you with this undifferentiated heavy lifting. All right, let's jump in. I've spent a lot of time being on call, and I'm sure many of you are familiar with it as well. But just to make sure that we're all starting off on the same page, what does it mean to be on call? To me, it means spending some portion of your time being available 24/7, ready to respond to any high severity incidents that might occur. It means getting woken up at times that you'd rather be asleep. It means having your laptop near you at all times and trying to stay within range of internet services. And it means having to diagnose potentially complex problems while half asleep. Now, there might be a little bit of variation by person or company, but these 4 points generally hold true across most of the industry. Now, I won't lie, it's not fun being on call, and I'd say it's one of the least enjoyable aspects of this industry. And I don't think that we'll see the concept of being on call disappearing anytime soon. As our CTO, Werner Vogels, likes to say, everything fails all the time. Developers will never write perfect code, and will never have perfect applications with no errors. However, just because it's necessary to be on call doesn't mean that we can't do anything about it. And in my experience, the most effective course of action is to reduce the amount of time that you need to spend on high severity incidents by streamlining your processes, not just for your customers and your company, but for your sleeping habits as well. So with that in mind, let me tell you about how we approach incident response at AWS. So to start with, I'm going to give a high-level breakdown of the different actions taken in response to a high-severity incident in a way that you'll be able to apply to your workloads as well in order to reduce the mean time to recovery. So at a high level, first up, what is the scope of the incident? That is, how many people or customers are affected. Secondly, we have the severity of the incident. What does this mean for your customers? How does it affect them? After these first 2 actions are completed, you can now quantify how severe an incident is. This means that if you have multiple ongoing incidents, you can now prioritize and choose where to focus your efforts first, updating status dashboards, notifying customers, that sort of thing. The 4th action to take is to determine the root cause. Now, people often try to start at this step, and it makes sense in the heat of the moment. You just want to fix the problem straight away. But taking the time to step back and determine the true impact of an incident is a critical step before starting on a root cause analysis. And once you know what the root cause is, things start to get a bit easier, and you can start to relax a little bit. This is because the 5th and final action is writing and deploying a fix. Now, this is an essential step to resolving most incidents, but one that I won't go into much during this talk. This is because it's usually the first 4 actions that are the ones that require a lot of your time and brain power, which in my experience are in short supply when you've been woken up at 2 in the morning. So that's what I'm here for today. It's to show you the ways in which you can use to reduce time that you spend on high effort parts of this workflow to allow you to prioritize and resolve incidents faster. So, from the top of the list, how do we determine the scope of an incident? Determining the scope is one of the most important actions to take quickly at the start of an incident. This will guide how you respond to it from both the technical and a business perspective. And until you know the scope of an incident, you can't effectively respond to it. Let's take a basic web application as an example. Now, when an alarm goes off, and I don't know about you, but when an alarm goes off, it never tells me exactly what's going on. It'll tell you that there's increased error responses from your application. It might show you that you have a 30% failure rate on calls to this service, which is useful to know, but it doesn't tell us the whole story. What do I mean by that? Well, let's assume that each of these little user icons are 10% of your users. That 30% failure rate could be 30% of your customers are impacted and getting only errors. It could be one single customer doing large numbers of calls and receiving errors on every request. It could be that 100% of your customers are just getting errors 30% of the time. Often, the only option you have to find out the answer is checking application logs via CloudWatch Logs or whatever log aggregation service you may be using. But that takes time, and time is critical when your service is potentially down. So an easy solution to this that I've used to great effect in recent years has been CloudWatch Contributor Insights. Contributor Insights allows you to pinpoint the top contributors in a high cardinality dataset. And what this means is that you can use it to quickly zero in on how many customers are impacted and who they are without having to dive into the logs yourself. So you can see from the graph on the left here that an incident occurred where almost 25% of customers were being impacted. And you'll notice on the right that of the almost 1,400 unique customers, 3 of them account for over 90% of the failures. So being able to access this data at any time reduces how long it takes you to determine the scope of an event down to just seconds. And keep in mind that this is showing the percentage of customers impacted on the left, not just the API call rates, which gives us a better idea of the true impact of an incident. And while on the right, we can see the customers who are receiving the larger number of errors as well. So you'll find these are often much more meaningful metrics and can provide a more detailed view of your system than that basic 30% of your requests are failing that your alarm may be telling you. And if you had to query these logs yourself, this step can take a significant amount of time, particularly to get to this level of detail. So let me jump into the console and I'll show you how easy it is to set up Contributor Insights to extract this kind of data from your logs so that you can determine the scope of incidents quickly with your applications. Okay, for this demo, we're going to start on the CloudWatch console. We'll just go down to Contributor Insights down the bottom here, and you'll get this splash screen where you can create a rule to get started. Now, there's a bunch of sample rules built in, and these will let you build quickly if you've already got things built on top of AWS services and outputting logs. For example, if using API Gateway, you can get things like the faults per IP address, or the faults by route and HTTP method, for example, such as the path in your API and split by GET, POST request, etc. But let's click on faults by IP for now. And what we'll see is that you get a contribution by IP down here. And the contribution is like the unique key that you're measuring. So this is the source IP address that has hit your API gateway. And this will then count the events that match the filter below. So you can see that we're filtering here on status and where is greater than 499. So any 5xx errors will be captured. And finally, for the data that we're recording, we have aggregate on count, which is to count the number of matching events. You can also use sum here to get the sum of a provided field, for example, to capture the amount of data transferred per IP if you're logging request sizes. You can also use some of these sample rules for things such as Route 53. So you can see the number of queries by domain name to see what domain is being queried the most within your VPC. Or you can use VPC flow logs to find the top IP address sources that have rejected TCP connections, for example. But for this demo, let's just make a custom rule. Now, you're not limited by the services given in the samples. Any JSON logs pushed into CloudWatch Logs can be used. So let's assume that our logs look something like this. Now, we have a server address, which is the IP of our server. We have a response code, which is the HTTP 200, 300, 400 sort of error. We have an API name, get events in this example. We'll have a username, so we're able to look for unique users, for example. We have an error message, which tells us what went wrong. And finally, a request ID to allow for correlation of events. So with this in mind, let's make a rule to find the failures per API. So let's give it a name, failures per API. And I'll select the log group for my application logs. And so for this contribution, we'd set this to API name so that we can track the events per API. And I'll set the filter response to greater than 499 so that we can see those 5xx responses. And I'll hit create. It'll take a minute or two to backfill the data, so I'll just fast forward so that you don't need to wait with me. Okay, now we're starting to get some data through, and we can see the failures per API. So we can see a bit of a baseline of failures, which is probably a baseline for this application. And it seems fairly low and consistent. But we can also see that this getEvents API is having a lot of problems, and we've got a huge spike here. So it's starting to recover by the looks of things, but it gives us somewhere to start an investigation. And this is a really powerful tool, and it gives us the ability to view metrics across all sorts of dimensions. For example, we can also show events per username to find the number of impacted users from this failure. Secondly, we have the severity of the incident. That is, how are your customers impacted? So let's continue with our web service example. You've just received an alert for a 30% failure rate. And let's assume that we've determined the scope and it's not one impacted user or group of users. What we found is that all users are seeing a 30% failure rate across the board. So how do we determine how this actually affects your customers? What is your customer experiencing? And does this failure cause them to be dead in the water? Or is it just a minor cosmetic issue in your application? Now, how to test this depends heavily on your application, but one thing that really helps to track the true experience of your users on your system is to run synthetic traffic through it and track how it's behaving from a user's point of view. And this is where CloudWatch Synthetics comes into play. So CloudWatch Synthetics allows you to create canaries designed for monitoring websites and APIs. And this works by accessing the exact same routes and performing the same actions as a real user, while taking screenshots of the pages and a HAR capture log on the way, allowing you to easily discover what has changed to cause the failure. So we can see failure to load certain elements or inspect screenshots to see what a customer would see when trying to use our service. And it can also be run against APIs to determine if they're responding in an expected manner and produce logs of the anomalous responses. So once we know how this incident is impacting our customers, we can more accurately determine the path to resolution. So let's go into another quick demo so that you can see how this works. So there's a lot of possibilities with CloudWatch Synthetics. So I'll run through a few of those real quick. First of all, we've got a basic page load canary here. So what this is showing is that we've had no issues in the last 24 hours. And I've also got a little graph here that shows all of the runs of our canary. And I can click on one of these to view the details. So what this will show me is the single step of loading the page, which was successful. It'll show me the screenshots, so I can see my little pet adoption site here is loaded correctly. And I have all the logs as well, so we can view anything that our canary code has returned during its run. And then we have the HAR panel, where you can see for each element on the page how long it took to load things such as the DNS lookup, connecting, sending, receiving phases, etc. And you can also view the request and response headers for every element, which is super useful because now you can see what's gone wrong with your application without having to be there at the time of the failure. We've also got monitoring and metrics from our canaries automatically. So from our monitoring page, we're able to get metrics such as the duration, and you automatically get this band here for the expected duration based off of a predictive machine learning algorithm. So this gives you something to alarm against without having to figure out and manage thresholds manually. You also get all the other expected metrics you'd want to alarm on for a web service, such as success percentage, 200, 400, 500 errors, etc. So let me show you how I would make one of these canaries real quick. We'll navigate back to the home page and click on Create Canary. Now, we've got a few built-in blueprints here, such as the heartbeat monitoring to load a single page. We have API canaries where you can send a list of post or GET requests to different endpoints. We have a broken link checker. We've got a Canary recorder, which includes a Chrome plugin to let you record complex workflows. And we've got a GUI workflow builder where you can define a number of steps and it'll generate the code for you. So in true demo fashion, I've already filled this one in, as you can see. So I've entered a Canary name and I've put in an endpoint URL, which is the pet adoption site you saw in the previous simple page load example. And we're going to do two things in this workflow. We're going to change the selected pet types drop down to kittens, and then we're going to click and navigate to the search pets button, which will load up and wait for the next page to load. So if we scroll down a bit, you'll be able to see the code here that it's generated for our steps. First of all, to click and enter kittens in our search box, and then to click on the search button and load the next page. All right, let's create our Canary, and I'll just jump ahead 1 minute so that it can finish a test run. Okay, we've got our Canary created, and it's had a successful test. So this is similar to what you saw before, but now we've got 3 steps showing. To load the page, to enter kittens, and then to click on the search button and wait for the page load. So if we check our screenshots, we've now got a screenshot at the start and end of each step. So we can see here where our input is starting, and then kitten is entered in our selector. It might be a bit small, but you just have to trust me that I've entered it there. And then we can see the click of the search button and wait for redirection. So down the bottom here, we now have cats being shown instead. So when you want to make this into a production-ready Canary, the next step would be to make sure that you validate the page that we've navigated to is showing the correct data to make sure that your customers are seeing what they're expecting to see. Now, you're able to alert on this, you can view the logs, you can view the screenshots, and you're able to see exactly how your customers are being impacted by an incident. Up next, we have prioritization. So prioritization is relatively easy once we know how many customers are affected and how they're affected. There isn't any tool or service that I'm aware of that will assist you greatly in the prioritization of multiple incidents, but an important lesson that I've learned over the years and that I would love to share with you is to make sure that you have a clear definition that the team has agreed upon for 4 key aspects. If these are determined ahead of time, it makes prioritization take a matter of seconds. So first, what is your criteria for a high severity incident? This sounds really simple, I know, but really think about what you, your team, and your company would classify as a high severity incident and discuss it. You'll find surprisingly differing answers within most teams. Second, incident handling processes. So that is, what do we need to do before we can downgrade the priority of an incident? For some people, this is mitigating the customer impact. For others, it's diagnosing the root cause, or maybe when your alarms have recovered. But personally, I'd recommend all 3 of these criteria be fulfilled before resolving or downgrading the severity of an incident. Third is having a clearly defined escalation criteria. So realistically, a single person can deal with a single incident. So having a way to engage more people quickly while still being able to focus on resolving the incident at hand really helps to create a smooth and fast response to any potential incident. And last, but definitely not least, user ticketing system. Being able to track what happened, having notes from engineers as the problem is ongoing, links to graphs and logs and source code, etc., can really help in many ways. For example, when you need to get another engineer up to speed or hand over an issue, you now have a log of what's happened. It's also helpful when a problem reoccurs. You're able to look up how someone solved this error last time in the case that it wasn't fully resolved by that attempt, saving you from attempting the same thing again. Now, these 4 points will give anyone on your team the ability to quickly and accurately prioritize how to respond to an incident. So I'd typically suggest having them written down at the top of your runbooks or another place that you can quickly and easily find them. Next up, we have root cause analysis. Now, the key to finding the root cause of an issue quickly is isolating who was affected and how, which we've already covered. So this gives you a good idea of which component is likely responsible for the failure, which is the starting point for your root cause analysis. And there's a few options here that can help you to discover the root cause quickly. The first is building further on contributor insights, which we can use to quickly and effectively look at your errors across some other dimensions, such as the errors per server, to see if you have a bad server or instance in your fleet. or for example, the errors per API operation. So in this example, we can see from the graph on the left that it's not a server problem. They're all showing similar rates of errors. But if we check the graph on the right, we can see that our errors are only happening on that getEvents API call. So this gives me a really specific section of our code base to look into. But I still don't know what the actual error is. I just know what API operation is failing. So what do? Well, the situation that we all often end up in is that we have some metrics showing that the system's having a problem, and we have a big pile of logs. And traditionally, correlating a metric response to a log line is challenging. So you often see people searching for terms like error or fault or something similar in their logs and trying to match up timestamps for when those happen to find the relevant metrics. But that's not very effective or accurate. However, there's two key features that were released for CloudWatch in recent years that, when utilized together, can make correlating metrics to your logs really easy. The first is CloudWatch Logs Insights, which provides a flexible query language on top of CloudWatch Logs, allowing you to analyze and visualize your log data on demand. So for the purpose of application or transaction logs of a system, I found that this was the missing piece to allow for a fully serverless and managed log ingestion and analysis solution. So you can see in this example screenshot that you get auto detection of fields within your logs, allowing you to filter and aggregate based on whatever your application is reporting. And the second piece of the puzzle is CloudWatch Embed Metric Format, or EMF. EMF allows you to embed metrics inside of your logs, allowing you to push low cardinality data right alongside the high cardinality data very easily. So I know for myself, I had to see these two in action to really see the magic that can unlock. So let's jump into another demo, and we can see how we can diagnose a problem quickly and easily using CloudWatch Logs Insights and EMF. So as I mentioned, EMF logs allow you to correlate the high and low fidelity operational data coming from your application. So let's start with a quick code example, and then I can show you what you get from that. In this case, we're using Python, so all I've had to do is pull in the metric scope decorator from the AWS Embedded Metrics library. I then wrap my function inside of this decorator, and this gives us a metrics object. And what this lets us do is it allows us to put metrics such as the processing latency or number of widgets that we're generating, which is our low fidelity data. We can also set high fidelity data via properties, things like account ID or request ID, things that you don't want a high level metric dimension for on every request, but you do want for debugging purposes later on. We're also able to add this into our exception handling, so we can add extra properties or metrics as part of our native error handler in our code. And that's it. That's all I need to add in my code to emit EMF logs and metrics. So what does this get us? Well, when our function finishes, the metric scope decorator bundles up all of the logs and metrics and sends them off to CloudWatch, resulting in this. So we get a few built-in things when we run in a Lambda, like the memory size and function version. But we also get all of our properties here, such as the account ID, device ID, request ID, etc. And this is really useful, since now you're able to look up from a failing customer request ID to find not just a log entry about the success of a transaction, but also all the metrics and properties generated from our request at the time. You also get low fidelity metrics, such as processing latency and widgets down here, as well as this auto-generated AWS key, which includes which metrics and dimensions to turn into CloudWatch metrics. So what about those? Well, what we end up being able to see is the low fidelity metrics are available in CloudWatch, such as the processing latency and widgets. So we can use these like any other CloudWatch metrics for alarms or dashboards and so on. But one of the big benefits here is that we can correlate back from the low fidelity metric to the high fidelity data like request or account ID, so that we can investigate problems much more easily. And this is where CloudWatch Logs Insights comes in to tie it all together. So CloudWatch Logs Insights has a really broad feature set that honestly deserves a full session on its own. But for now, let me show you a few quick and easy queries that you can use to get started. So if I just run this default query, we'll get a list of events in our logs from the last hour for our log group. And I can expand any of these log entries. And I'm able to see every field in these JSON logs automatically. And as you can see, these are the entries that I showed you just before. So what this means is that I can now filter and query on any data in this log. For example, I can add in a filter where success equals 0 and processing latency is greater than 150 to find slow and failing queries. And now I can pull out all of the relevant logs to see what happened. If I want to download and process these elsewhere, I can also export them to CSV file or use Markdown files to paste the results inside of a ticket to share with other engineers. And honestly, this is one of the strong points of EMF. I can emit hundreds of metrics on my functions for very little cost, since we only evaluate them at the time of an incident. This means that I can still utilize low fidelity metrics for alarms and dashboards, but I don't have to plan ahead and either pay lots for metrics that are rarely used or potentially not emit metrics that could be important in resolving incidents faster in the future. So let's recap. We've discussed the 5 key actions to take in response to a high severity incident. Firstly, the scope, which, as we've seen, can be quickly measured through the use of CloudWatch contributor insights. Secondly, the severity, which can be determined with CloudWatch synthetics and knowledge of your architecture. Third, we have prioritization. The 4 key takeaways are to define your incident criteria, your incident handling process, and escalation processes clearly, so that you don't need to spend time figuring it out in the middle of an incident. And of course, to use a ticketing system to track your incidents. The 4th key action is root cause analysis. From the demo I just did, hopefully you can see the benefit and utility of CloudWatch Logs Insights and the ability to correlate metrics with events that the embedded metric format logs can provide to really help you find the root cause of a problem. And the 5th action, creating and deploying the fix, which, although it's an important step in resolving any high severity incident, it's a little bit outside the scope of this talk. Now, this is just a few of the tools that we have available. AWS provides a far larger suite of management tools and governance services, so you can get a consistent set of modern ops tools to set up, manage, and govern your applications and resources. These tools are built from the ground up to be optimized for cloud scale. And in this session, we've only covered a fraction of the possibilities that they can provide. I also want to quickly add that although we've been discussing how to achieve these goals using purely AWS services, we also have an extensive partner ecosystem that provides further tools that are able to integrate easily with the AWS platform. If you found this session interesting, be sure to join some of the other sessions listed in the IT Administrator track. I would check out ITA 05, Get Started with Monitoring and Observability on AWS, and ITA 02, Introduction to AWS Tools to help achieve operational excellence. Also, take a look at both our management and governance blog and the AWS DevOps blog for some more related content. And also reach out to us. There's a contact sales button at the top of aws.amazon.com, or go to the link that you can see right now and get in touch with our accounts and solution architecture teams. We'd really love to help you build something. If you want to learn more about DevOps and how you can utilize AWS services to help make your life easier, then we've got a lot of options to help you out as well. We've got over 45 online digital training offerings that are available on demand. We also have a 3-day instructor-led course, DevOps Engineering, on AWS that dives even deeper. And you can also gain credibility and confidence with 2 related certifications in this space, and much, much more. So check out aws.training/DevOps. Thank you. It's been great sharing this with you all today, and I hope that you can use what we've covered to help reduce the time that you spend on high severity incidents. And while we're on the topic of metrics and observability, please complete the session survey as it provides important metrics that allow us to deliver the best Summit experience to all of our customers. So if you enjoyed this video, don't forget to give feedback, and thanks for watching.